Today we connect an SSD1306 with the Framebuffer library to a Pico. Today we want to take a look at displays with the SSD1306 chip because it's a cheap and still good solution for many Raspberry Pico projects. So let's take a look how to deal with this display with the drivers and the Framebuffer library. Okay, let's start, and the first thing you need to do is to install the SSD library. I did this already, as you can see, but you will just search for SSD1306 and you see the Micropython library, and you can directly install this from here, so you don't need to use the package manager on the shell, just install it. Afterwards you will find under your libraries the SSD1306. You don't need the other ones here in this case, so just this one. If you open it, so you can open this directly by double click, you see the driver level, so different addresses which are defined as constants here, which might be accessed, but you don't need to bother with that because it's all done by the library. So I will close this now. What you see here already is that the Framebuffer library is used, and we will use this as well. And we will just import also from the machine library the pin and I2C class, because we need this even though we have this library here from SSD imported. As always, we import time because we want to have some delays maybe, and we need now the SSD1306 library, and it's enough to import the class SSD1306 I2C. And we need the Framebuffer library later because we want to use it to show a picture on the display. The first thing you need to do is you need to define your I2C level. So that means you need an I2C object which which fits to the address where you did connect it. I connect it to pin 0. I will show this here on a picture so that you can see how I did to connect this. And the clock pin is pin 1. And then you need to define a frequency and take a look into the data sheet, or for this one, take my frequency. This works. And now you need to define the real display object which we will use. I will call this OLED now. Just to get this better readable, let's put a space inside. And now we take this SSD1306 I2C from our library. And there are 3 parameters you have to hand over, and this is the width, the height, and the object for the I2C interface. So what we did before or created before, and width and height is 128 and 64. If you take a look into the library and we take a look at the class which we are now using, you see that width, height, and the I2C needs to be handed over. You can change the address as well if you have another one or not the default one. But it's set. If nothing is handed over, it takes the default one, which works in my case. And this is already the most important thing. Now we can already start to show something on the display. We use the text method, and yeah, let's just simply put something YouTube surreal, I don't know. And what is now important is to put the X and the Y coordinates, and then there is something. I will explain this in a second. Maybe we start with this first, and we put an OLED show on top. Okay, and if we run the script, we see something on our little display. And now you can, for example, just change the X position, or we can change the Y position. And let's set this back to 0 and take a look at the last part. So I mentioned this. When we set this to 0, it disappears. So we can't see anything on the screen now. And the reason is that this is the color. So we have a black and white, and 0 is black and 1 is white. Yeah, and we can bring it back, setting it back to 1. And we can also take a look at how to change the background color. So there are 2 ways to get this working. Let's start with the first one, which means we fill the display with white or black color. So as we noticed, 1 was white text, so 1 filling it with 1. Let's do this. Means the display gets white. And if we change the color to 0, so to black, then we can see the text again. If we set it back to black, we can't see anything because we need to change the color back to white. There's another method, and this is the invert option, which means you can invert the display, and this is nothing which comes. So the fill comes from the Framebuffer library, and the invert is something which is defined here in our SSD1306 library. So let's use the invert function, and we set it to 0 first. So if you say 0, nothing happens, but if you invert it to 1, you see that it's working, even if here is a 1, so the display gets white, but you can still work with the same color coding. So this is a nice function because you don't need to change your normal behavior if you want to switch from a white to a black background or vice versa. But I want to get rid of this because I don't want to have this inverted. Okay, let's take a look what other functions are available, and you will notice that there's not much more in. So we have power off, power on, okay. Contrast does make sense on this display. Invert, we saw this show, okay, you can turn the display on and off without turning the power on and off. So that's it, more or less. So let's take a look in the Framebuffer library. I mentioned already that the Framebuffer library is the one we used already with the fill and also with the text option. And now what we can do now is to use some other functions available. Let's maybe start with the ellipse. Can create an ellipse, and that's quite easy, honestly. We just need to enter a few attributes. So we use our object OLED, we use the ellipse function, and you have to say where you want to place it, and let's put it in more or less the middle, not exactly the middle, but 40-40. Now you need to define the width and the height. Let's do a circle by taking the same color, and we can just start this now, and we get a circle. And you can put another attribute at the end, and this is if you want to fill this circle or your ellipse. So let's put a 1 in, and you see it's now filled. If you change this to false, it's again just the outline what you can see. So that is how you can draw an ellipse, and as you saw, you can use also other things like the rectangle. Also here you need the X and Y, and then you need, or maybe we do this quickly as well. So rect is the function, and let's put a rectangle, maybe we put it a little bit more on the right side to our circle, same height maybe. And now you have to say, so from the 70 on the x-axis, let's say it goes to, I don't know, 90. And from the y-axis, it goes, I don't know, down to 50. And let's draw this now. And you see there's argument missing. If you usually you can see what arguments are missing if you have the right environment set. But let's just take a look here, and you see I had the width and the high, but I need to specify a color. It's mandatory. So okay, we take the one for white, we draw it, and you can see it, but maybe it was a little bit too high because this is not an absolute coordinate, this is relative. So when we put it down to 20, and now the same for this one, we get our rectangle. So it's not an absolute coordinate in this case, it is the relative width which is added to the 70. Okay, what you can also see are some other methods, and we want to take a look at scroll and blit. Let's start with scroll, it's easier. When we take a look at Thonny, I created a little ellipse and rectangle now on top of our display. You can see this, and we want to move this on our screen. So we will create a little loop. Let's say we create a loop with 60 steps. And of course, we want to show each step. So we can remove this one here. And afterwards, we will use the scroll function. And now you have to define by what gap you want to move it, or what step. And let's say we keep it on the X position and we move it by 1 on the Y position. To see this a little bit better, we first start this with a sleep of, let's say, half a second, and go. And you can see that this is now going slowly down to the bottom. And it's too slow. Let's say we can stop this and do this now without a sleep. And you can see how this is falling down. Okay, now let's take a look at the blit function. And this is a little bit more complicated. And to explain this better, we do directly an exercise. And after this exercise, I explain how to get the raw data for the picture. So for this exercise, I prepared a binary array, which I will paste now. So you see this is an array which describes a picture. It's a byte array, and it has the resolution, so that's why I called it 40 or 40 by 40. We will take a look how to do this, but just let's keep it like it is now. And I also set a comment here for all other things we did, so we have an empty screen now. So what you now need to do is you need to create a picture, or however you call your variable here. We use the Framebuffer function, which means I can't write anymore. So we use the Framebuffer function. So we create a Framebuffer, and for that we need our array. So let's take our array. This is because the blit function draws a Framebuffer over another Framebuffer. That's why I need another one. So I create a complete Framebuffer, which is afterwards placed on top of the existing one. So what we might have done already. So you need to define height and the width, and as I said, this is 40 by 40, so, or 40 pixels by 40 pixels. So I take this, and then you have to define the color coding, and I take mono and horizontal. This is because, and you will see this later, I created a horizontal mono array. And now you just need to set the picture to a specific position. Let's take 40, 40 here. And of course, show it on your screen. Give it a go. This was a little bit too low. Again. And you see the little sailboat, which is hidden in this binary array. As said, it's a frame buffer on top of another frame buffer, so we can still, of course, put other things additionally on our screen, as we can see. And this is now written on our real frame buffer, let's say, and then we use this frame buffer and the Blit function to put the frame buffer which contains our picture on top of it. And of course also our scroll works. Let's give it a try. So we move the whole frame buffer, because if the frame buffers are merged, it's easy for us to move or deal with the complete frame buffer. So to sum this up, what is a frame buffer? A frame buffer is nothing else than all the pixels of a given resolution in a buffer, so that the display can be easily generated by just having the information. Is there a pixel? In which color is this pixel? So in this case, it's just on or off, and this for the complete resolution. So frame buffers are on a lower level. We need to use them for this display because there is not a library which is on top of it, so we need to work with frame buffers. And what we did now with the picture is also to have more or less a byte array with information. Is the pixel on and off, on or off? And then we put this in a frame buffer. We merge the frame buffer with our real frame buffer or operating frame buffer, and at the end we have a resulting frame buffer with pictures and other things, and that's it. And now let's take a look how to create this byte array to get this picture. So the first thing you need to do if you want to create a byte array is you need a picture, and you should already shrink the size. So I took now a 64 by 64 size, so pixels, 64 by 64 pixels image, or I shrinked it down to 64. And then what you also should do is, so you should erase everything which could disturb your picture, which is somewhere here around. And what you also should do is to set it to black and white, especially if you have just a black and white display. But even on color display, be careful with colors. On a byte array, it's not that easy. My method, which I explained, is now just for mono. So black and white is better than having also shades and different degrees of brightness. So I have now the sailboat in black and white, and that's the easiest thing to do. And how do we get this converted to a byte array? So there are several ways. GIMP has the possibility to create some output formats like this. Then there are online converters. However, I will show you the way today using the Python script image to byte array. This is a little Python program which will convert an input to a byte array. And you can also specify the resolution, so that you have the path to the image which you have to define, and then width and height. So it should fit the image size, but maybe we do this shortly. So I copied already my sail pictures in a folder, and I have the image to byte array script here as well. You need to have installed Python, of course, and then it's a simple command, so the Python 3 and then the image to byte array Python script. As said, the link to the file and the size of the picture you want to have as an output. Ideally, it's already also the input size. Then there shouldn't go anything wrong. And if you start, you see the result. And you see that there's a lot of white and black, so XFF or X00. But there are also some little other things inside, because I had some brightness shifts in my picture, and then of course it's not FF or 00 anymore. This is still working. However, on my display it can be just on or off, so it would be even better if I just find XFF or 00 here, then it's absolutely clear. You can copy this now, and this is exactly what I did before. So I prepared, as I said, my picture. I just copy it into my program. Well, the last little exercise, and this time I use my picture again, but I did put the coordinates by my own in a loop, so I don't use the scroll function. I use a loop where I calculate my coordinates, and it's looking more complicated than it is. I just have 0, 0 at the beginning, and then it's increasing one by one, and just if it reaching the border of the screen, it's inverting, so it's decreasing again, and then increasing when it's reaching the other side of the screen. Always on top, so that's important that this is second, my text, so on top of my picture. Otherwise, the picture would be on top of my text. And this is always on the same position. And then we will see this. Let's give it a go and take a look on the screen. First, I wanted to use a random number so that also the path is changing, but I think this is a little bit too much for today. So now we just simply use the borders, and we are just increasing X and Y and inverting the direction when we reach the borders. But I think this is enough for today. So I think we learned a lot about the SSD1306 displays, and they are quite nice, especially for the good price. As you know, I also did a little video about the Pimoroni display, which is a little bit more expensive but has tons of features, so that would be an alternative. I hope you enjoyed it, you learned a little bit, and we see us next time. See you next time.